Recording is started. نحل بقى النهارده June 2016 paper 6. So our target نحن نحل 2016 variant 1 for now. ليه بقى هنبدأ من الأول؟ Like I'm just going sequentially frankly. بس عايز أتكلم عن paper 6 الأول before we solve. إيه بقى اللي paper 6? Let's scroll through it. تعالوا نعدي فيها. Like if you have the exam, flip through the pages معايا وأنا بفلip. If you look at the number of questions اللي في الإكزام, you'll see there's one. سؤال شكله كبير واخد سبيس كبير وسبيسز كتير قوي. Question 2, question 3, question 4, and question 5. So it's about 5 questions. Remember, this exam is 1 hour long. So it basically gives you about 10 minutes per question. Now في ناس منكم شافت السبيس الفاضي ده هتكلم عنه بعدين تقلقوش. But لو هتاخدوا بالكم بقى من ستايل بتاع الكويستشنز عامله ازاي. One question is from unit 1. هيبقى يا balancing يا spring يا time يا mass بيتقاس حاجه كده. Another question is from thermal physics. بس ده مش سؤال thermal بصراحه، ده سؤال general measurements عشان كان عايز يحط 5 درجات somewhere. السؤال اللي جاي ده على electricity. رسم هو السيركت. He asks you to calculate stuff. هنحطها احنا في التيبل. And he'll give some conclusions or responses based على الquestion اللي هو عايزه. Most of the answers are here. سؤال الثيرمال خلاه what we call a planning question. سؤال الثيرمال خلاه what we call a planning question. Planning question يعني you are the one who writes down the steps of the experiment. Now this looks scary. يعني انت متعود على الحاجات دي في الانجليش يسيب لك space كبير because you're going to write some kind of some kind of composition. But هو basically اداك الsteps هنا. The examiner is usually kind of lazy في الحاجات دي في planning questions because he does want to scare you frankly. بس في نفس الوقت هو اداك الsteps هنا. So it's basically part A, part B, part C, part D for the question. So هو كسول يعني. He doesn't want to split it up. Then the fifth question is about waves. So you'll notice that he usually gets 1 question per unit. So does nuclear physics come in paper 6? Absolutely not. ما يقدرش يعمل experiment في paper 6 that you cannot do in real life. And you as a student, whether you're year 9 or 10 or 11 في ال O level أو year 9, are limited to certain types of apparatus. Rulers, stopwatch, balance, lens, basic circuits اللي هو حتى fixed resistors و variable resistor وشكرا اللي هو حاجات كده. Maybe a light bulb كمان. يا سلام ده دلعك قوي. Because he knows that, forgive me for the statement, students are stupid and they can't be trusted with anything that's too dangerous in the lab. Imagine if he gave you guys radioactive isotopes. I swear to God هلف في ظهري لو احنا في لاب ولا حاجه هلاقي مثلا مصطفى حط العالي النيوكلير ايزوتوب في بقه زي طب دوقها كده ليها طعم ولا لا، والاقي بقى الايه كارثه بعد كده حصلت. عارفين الميم بتاعت مستر انكريدبل وبعد كده بيقلب اسود. That's basically what's going to happen then. Me teaching a lesson about nuclear physics. Anyway, memes aside. نبدأ بقى. I'm going to read this slowly, but then I'll show you when can you skip the reading and when you don't need to skip it, when you should you read. فتعالوا نقرا مع بعض. Remember, he will give me an experiment already described, already done. يا إما هناخد readings, يا إما هنcalculate حاجات, يا إما هنطلع بconclusion, or we'll come up with some kind of improvement to the experiment, etc. A student is determining the weight of a meter rule using a balancing method. ده اللي هو عايز يعمله. New news today, only focus. Exactly. The apparatus shown in figure 1.1 is shown. فهو موريني ruler وموريني weights وحاطط pivot and so on. The student places the load P on the meter rule at the 5 centimeter mark. She places the meter rule on the 45 centimeter mark. حطيتها هنا. She places the load Q on the meter rule and adjusts the position so that the meter rule is nearest possible to being balanced. ماشي. الرغي ده هيخلص امتى؟ على فكرة this is a problem with paper 6. You will get bored. Okay, let me change where this is. Okay. فحطت اللود Q هنا. Then she measures the distance X between the pivot and load P. She measures back the distance Y from the center of the load Q to the pivot برضه. She repeats the procedure by placing load P at 10, 15, and 20 and 25 centimeters. The readings are shown. Okay. الناس اللي لسه داخله احنا بنحل June 2016 paper 6 اول exam the paper 6 في اول question في اول exam. Okay. Excellent. you'll notice how he just spent the entire thing and I got nothing out of it. هو بس بيشرح الستودنت عملت الاكسبيرمنت ايه. These experiments get repeated. فانت افهمها مره وبعد كده تلاقي الباقي سهل. So basically he put a ruler down, حط loads على الناحيتين, and he's trying to balance the ruler. Then he changes where the mass is on both sides until they balance again. And he just wants to make sure it balances at different distances. Okay. هتقول لي okay. Done. Easy. Then what you missed? عايزين حاجة أصعب شوية. ولا احنا نسمع مش حاجة. مديني table بيقول لك for each value of x ده calculate a ده where a is equal to p times x, where a is equal to p times x and p is 1. يعني نعمل ايه يا ترى؟ هنعمل p اللي هو 1 times x عند كل واحدة. So if this is x هنعمل 40 times 1 هتبقى 40. وفي كل بقى حتة في التيبل 35 times 1 ب 35. 30 times 1 ب 30. I'm gonna zoom in a bit because writing this down when it's not zoomed in is challenging. But there we go. 25 times 1 is 25. 20 times 1 is 20. فادي الارقام. خدوا بالكم هو اللي قال لي اعمل ايه. You just need to read and focus. Record the values طبعا in the table. P is the weight of the load P. Next. For each value of y ماشي for these calculate B equals Q times Y. ماشي يعني هنحسب B which is Q, I don't know what Q is, times Y. قال لي where Q is 0.8. ده معناه ايه؟ ده معناه ايه؟ بالظبط يا مالك exactly. فهنعمل الواي ده times 0.8 ونحطها هنا في B. So هطلع الكالكوليتر. I think I left my calculator in the other room. طب my phone will suffice for now, but I'll probably have to go get the calculator لما نيجي نشتغل في الجراف. فهعمل 42.5 times 0.8 يطلع 34. هعمل بعد كده 36 times 0.8 هيطلع 28.8. هعمل 30. انتوا فهمتوا بقى الليله خلاص. You're supposed to figure this out بقى by now. يعني خدتوا بالكم I'm just copying numbers. فيلا 24 times 0.8 ب 19.2. هعمل 17.5 times 0.8 يطلع 14.0. يعني في ديتيل صغير عايز اتكلم عنها. خدتوا بالكم وانا بكتب كتبت 0.0.0.0 هنا 0.8.0 ليه؟ هو في الفاليوز دي هو شغال 1 decimal place او 3 significant figures. انا اشتغل زيه برضه. اشتغلوا زيه برضه 3 significant figures او 1 decimal place لو هو كاتبها. حتى لو الرقم 14 حتى لو الرقم 1 هتكتب 1.0 مثلا. You have to show it غصب عنك. Otherwise all of this is worth a mark but because it's busy work. ساعات بيحط اكتر بس because it's a busy work. Complete the column headings. قصدي ايه بكلمة column headings؟ Again, هي حاجة بنقولها will be repeated in different exams. This is what we call a column heading. يعني الهيد بتاع التيبل من فوق. فالهيد بتاع التيبل لازم يبقى فيه حاجتين. Some kind of quantity slash اليونت بتاعتها. فهو سمالي الكوانتيتي سماها x وسماها y وسماها a وسماها p. هو عايزني احط اليونت. since x ده كان distance وهو قال لي اليونت في الباراجرافز اللي فوق هو قال لي انه measure the distance x والy بالسنتيمترز يبقى دي بالسنتيمتر ودي بالسنتيمتر. الايه بقى اليونت بتاعتها بص على الايكويشن. ايوه بالظبط. انا في ناس في الشات عسل والله ثانك يو. نيوتن سنتيمتر because A equals px. P is Newton x is سنتيمتر يبقى ده نيوتن تايم سنتيمتر. جميل عشان البي برضو نفس الايكويشن. now اللي فيكم فاهم هياخد باله ان هو حسب مومنت. واخدين بالكم هو عمل ايه؟ هو حاول يحسب المومنت. عمل force times distance basically. بس هو مش لازم يقول لي ان دي moments واحسب انت المومنت افتكر الايكويشن. هو هيديني الايكويشنز even if I don't know what they are. حلو جدا. حد عايز التيبل ده؟ The numbers are easy. We've spent a lot of time discussing things. فمفروض تكون لحقت تنقل النمبرز. We're going to go back and forth between them كل شوية. Next. Plot a graph of graph. نرسم جراف بقى. هنرسم جراف. But wait. بص بقى على الحلاوة. Plot a graph of A Newton centimeter on the y-axis. انتوا واخدين بالكم هو عمل ايه؟ انتوا مش واخدين بالكم هو عمل ايه؟ Against B Newton centimeter on the y-axis. مش واخدين بالكم هو عمل ايه؟ هو اداكوا ايه؟ اليونت. يعني الانسر بتاعت البيج اللي قبليها. بوم. يس بالظبط الاجابه دي. طيب زي الفل. وكمان قال لي مين على الواي ومين على الاكس. So always start by doing. على فكره one of the 4 marks على الجراف is you just writing the label. ف A نيوتن سي ام وتحت هنكتب B نيوتن سي ام. حلو. كتبنا الكلام ده. دي بقى مهم. الجراف المره دي سهل شويه عشان هو قال لي start the axis at 0 0. ساعات مش هيقول لي الجمله دي. Which will change the way we draw the graph. We'll see that later. But for now, we're just drawing an easy graph. So you start your scale at A 0 0. Yes, يا ريت الجراف كله بالايه؟ بالبنسل. يا ريت الجراف كله بالبنسل. عشان لو غلطت تمسح براحتك. وهوريكم حاجه. في اول الاكزام. You write in dark blue or black pen. يعني كل الحاجات اللي فاتت كتبناها كده بpen. You may use an HB pencil for diagrams and graphs. ارسم الايه؟ الdiagrams graph pencil لو سمحت. Now I'm just going to take a screenshot of these numbers عشان احطها على السكند مونيتور بتاعي عشان لما اجي اروح واجي من التيبل ما اقعدش الف كتير. So let me open up something like Paint or something just so I can drop that screenshot. That's okay. Now I have the table on my left side. Okay. بص بقى. Yes سلمى على طول سبقتيني. Every axis will have a different scale. عشان كده بقى عايزين نتكلم. نحط بقى السكيل بتاع ال A وال B ازاي؟ مش دايما بس you can. لازم ابص على النمبرز بتاعتي. Since we started 0 0 انا المهم عندي انا اخري هوصل كام. So in A انا اخري هوصل 40 وفي B انا اخري هوصل 34 which I could say is 35 or 40. فلو نزلت وبدأت بال A how many big squares do I have? Now zoom into the paper. Now I know you don't have zooming in but you can move closer to the paper which makes it easier. And I want you to mark كل 10 squares طالعة ازاي. يعني عايزكم تعملوا مارك كل 10 squares عامل ازاي. This will make plotting the graph or the scale much easier في الاكس وفي الواي عشان عيني ما تستغللش في وسط ما انا بعمل. فكل 10 small squares اعملوا داش. ماشي؟ طيب عملت الداش every 10 small squares. So I made a mark every 10 small squares. So we could either what can we do? أنا شايف ناس كتير like a lot of you are giving really good answers. So graph by 8, graph by 10, yes. 10 is the easiest. And here's my advice as lazy Muhammad Ali. Be lazy when you plot the scale. Choose the easiest scale you can do as long as it takes up most of the graph. Choose easy numbers and choose multiples of 1, choose multiples of 2, choose multiples of 4, and choose multiples of 5. So 1, 2, 3, 4, or 10, 20, 30, 40, or 100, 200, 300, 400. Or 2, 4, 6, 8, 20, 40, you get what I mean? 5, 10, 15, 20. Choose easy numbers. ما تقعدش توجع دماغك and try to come up with this weird convoluted scale of every square is 2.5 or 2.6 and then choose easy numbers. Even though we have a law that says that your points have to cover more than half the graph, this won't be very important today because of this sentence. Start both the axes at 0, 0 and شوفها in a different graph. So we're going to see that in a different graph. For now, let's plot these. So we want to plot A. This one's the easy one. So 20, 25, 30, 35. So I'll start with 0 and move every 10. So this is 10, 20, 30, 40, 50. Label the entire thing. So if you want to go every 8, that's fine. But I would prefer just going something even simpler. As long as it's still covering a decent portion of the graph. And on the x-axis, I will actually do the same. Because the numbers are very similar. Oh, oops, this is 10, 20, 30. هو مسحها كلها ليه؟ What's wrong with you? What's wrong with you? Okay. Okay. Now let's start plotting. The first point is 40 and 34. So 40 on the y-axis. Let's start from the smallest value so we can go from bottom up. So the smallest value is 20 and 14. For 20 here and 14. Now, if I were you, and this is I would do if I had a ruler مثلا with me, I would draw a very thin line or just put my ruler down so I can mark where these points should be. So this is 10, and this is 11, 12, 13, 14. I would draw two lines together. And once I do, I would mark their intersection, or at least I would just use my ruler to help. Nice. وطبعا when I do that, what can I do when I'm done? Just erase them. Make very light lines. Make very light lines. Next, 25 في y-axis and 19.2. So this is just going to be busy work بقى. So let's just do this hopefully as quickly as possible. For 1, 2, 3, 4, 5, my eyes. And then you have 19.2. Now there's no such thing as 19.2. So what do? 19. Just plot it at 19. I don't have space for 19.2, so just plot it at 19. Make your point, and then erase the lines. When plotting points بقى يا شباب, this is super important. When plotting your points بقى, guys, make sure you use either an X, like a cross, or a small dot with a circle. These are the things we accept. Don't go making like giant thick X's or like giant blobs. That's not a point. That's a blob. Don't tear a hole through the paper, please. Okay. Next up, yes, round them if you don't have the space for them. Next is 30 and 24. So 30 and then 21, 22, 23, 24. And here you go. We can delete these lines. Okay. Guys, the first two are simply just me plotting the points from the graph, from the table. If you don't know what I'm doing, what says it? 20 and 14. فأدي 20 وأدي 14. And I plot them on the graph. And then 25 and 19. فأدي 25. And the 5 here, 25, and this is at 19. Yes. Next up, so we have 35 and 28.8. You know what? I made a mistake. I should have played some non-copyright music. Anyway, 35, 1, 2, 3, 4, 5. Who cares? I'm not going to put this on YouTube. 35 and 28.8, so I'll plot that to 29. Or maybe I will. What do you guys think? Yeah. Okay. Distract from the torture. What do you mean? Is this torture? Finally, 40 and 34. Obviously, doing this on a sheet of paper is so much faster than on screen. 1, 2, 3, 4. At least I'm faster with my hands on a sheet of paper than I am on screen. Okay, dokie. We finally plotted stuff. No anomalies. Then what do we do? Well, we draw a line. What we have to draw at is what we call the line of best fit. Now, there are many ways of doing this, but here's something I would suggest. Just draw a line between the first and the last point and extend the line. And extend the line. Mustafa gets me. So extend the line. No, it does not start at the origin. And this is something that's super important. If the graph, it's always best fit. It's always best fit. If the graph does not start at 0, 0, I mean, the points in the table do not start at 0, 0, you don't have to go through the 0, 0. If the points naturally go through it, that's great. If they don't, that's okay. And besides, we don't want it to go through the 0, 0 because of the next question. Read along. Using the graph, determine the vertical intercept y. Determine the vertical intercept a, y. The value of a1b is 0. In other words, he wants the y-intercept. And if you don't know what this is your y-intercept. And what is this value? It's 6, exactly. Thank you. So the y-intercept here is a 6. So our value is a6. Show clearly on the graph how to obtain the value. Well, thank you. Gee, I don't know. Maybe it's thankfully because we extended the line and we had it intercept and we marked it. So 6. Okay. Calculate. There is a range. There will always be a range. That's a very good question. There will always be a range. But the range is usually like, I don't know, 1 or 2 squares above and below. Usually 1 square above and below, assuming you've plotted your points correctly. So 7 is acceptable. Yes. 5 is acceptable. Yes. Okay. Calculate the weight of the meter rule using the equation W equals Y over Z. He gave me some other equation. Y is what? 6 over Z is what? Well, he told me Z is 5. So 6 over 5. 6 over 5, which is 1.2. And since this is weight, the unit's in A, newtons. Okay? Now, Malak asks, if you get the wrong value of Y, there is something that we call error carried forward. As in, this error will be moved on here. So if you got this wrong, you lose this mark. But if you show him the working, let's say you wrote it as, I don't know, 10, Emil. So 10 over 5 is 2. If you show the working here, you get this mark. No problem. Again, what's W? He asked me to calculate W. W is a Y over Z. What's Y? We just got it. What's Z? It's 5. So what's Y over Z? 6 over 5. 6 over 5. Okay? No fractions. No fractions ever in physics. Never. Hope you get that. Okay. Before we take oral questions, I want to finish this question first. So just one practical reason why it's difficult to obtain exact results. This is a very common type of question, which is ABAC. So just one practical reason why it's difficult to obtain exact results. This type of experiment has a lot of problems, because here's what you're doing. You're getting a ruler and you're putting it on a pivot, and then you put masses on top. There are lots of mistakes that could happen. The following included. When you put this ruler on the pivot, it'll slide off of the pivot. It will not balance properly. And when you put masses on the pivot, they will slide on the ruler, because it's not like you're sticking them. He didn't say he stuck them. Other experiments do tell you they attach them with glue or putty or something, or tape. And then it's hard to balance, because every time you move one of the masses on one side, it'll fall over on the other. So it's a balancing nightmare. So you have so many problems in this experiment. I sent you a sheet which has all of these. This is what you'll need to read or study before your paper. But for now, I'm just going to use one of the easy ones, which is the weights or the masses cover the markings on the ruler, which makes it difficult to get the values. Another one, like I said, is also, it's difficult to balance the ruler. That's literally an acceptable answer. But I decided to just pick one of them. Okay. Next, I think this one's clear. So weights cover the markings on the ruler. The student uses an accurate electronic balance to obtain a second value for the weight of this meter rule. So he got another value of the weight. It's 1.2. Now, what was my value? Let's go back. My value is 1.2. His value is 1.24. This is a very common repeated question. You will get bored of this. Sometimes he asks this multiple times in an exam, not in different exams, in the very same exam. State and explain whether the two values agree within limits of accuracy. So what he's trying to ask is 1.24 equal to 1.2? Your math teachers would murder me, but I would say yes. Why that? Because all of these values are measurements, and measurements include human errors, like we discussed before. So, sorry about that. Yeah. So, yes, they are. So they are equal. Why بقى? Because the difference between them can be explained by human reaction errors. Like the difference between them is due to errors. Yes? So do you believe that these two values are equal? I would say yes. And this is how I would write the answer as yes. And I'll show you what I mean by no later. So yes. And we would say because the difference between 1.2 and 1.24 is very small and within limits of accuracy. That's our answer every time I'm comparing two values and they should be equal, but they're not exactly equal because errors cause them to be slightly different. Would your math teacher be disappointed? Very. But then he'll understand. I already said math teachers just murder me. Yeah, still. Yeah. Let me give you a scenario when these two wouldn't be equal. So let's say this is 1.24. It's a printed value. I can't change that. But let's assume you made a mistake with your previous calculation of W, and W ended up being, I don't know, 1.5 for some reason, or 2. I remember when I was asked, what if my Y was wrong? So let's say your value is 2. So is 1.24 equal to 2? Even considering errors? I would say no. I would say no. So if the answer is no, you would say no because the difference between 1.2 and 2 is very large and not within limits of accuracy. Do you see what you would do? You would use the exact same answer, but you would say large instead of small, not within instead of within limits. That's it. So how do you tell the difference if the difference is large or small? We'll understand that with experience. Like I'll show you what you can do later. Okay. I have a few questions about to answer. So if you get this above wrong, the question will let you know. Absolutely not, Malik. Sometimes he designs the question so that the answer has to be no. Sometimes he designs the question so the answer has to be yes. And sometimes if you open up your mark scheme and there's no specific answer, that's because it could be yes or no, depending on your values. So for example, if the previous graph that you drew was really messed up, not because of you, but because he designed it to be really bad. Like the examiner designed it so that your points are like this and they're far away. So when you draw the best fit, it would change a lot from one person to another. So you'd always get a different value of Y. What the examiner wants to see is, do you know how to reason two values or not? Like, can you come up with a conclusion based on the results in your hand or not? So sometimes yes or no are both acceptable answers. Sometimes both yes or no are acceptable answers. Before I move on to the next question, this took us a while because it's actually a very large question. It's 10 marks. It's a quarter of the entire exam. So any questions here? Ask away. Are all graphs going to be straight lines? 98% of them are going to be straight lines, if not like 100. Because there was one case where the graph was a curve, but he literally told you draw a curve through them. If he doesn't, it's always a straight line. And it's always a straight line of best fit. We have no other lines. Any other questions? Excellent. What answer is acceptable? Please type it down. Okay. How much of the value are we supposed to say yes? I told you I'll mention this later, but I'll mention something very brief. If the difference is less than, and you don't have to memorize this, you can tell with your own sense. If the answer is less than 10% of the values, then it's a yes. And what's 10% of 1.24? It's 0.12. Like if you divide this by 10, it's 1.12. The difference here is 0.06. It's very tiny. Here, the difference is 0.76. It's very large because the limit is 10%. You don't have to calculate this, nor do you even have to keep this in mind, because most of the time the values will be very clear if they're not equal or equal. One practical reason why it's difficult, well, think of it this way. مش دي ruler? Let's say this is the ruler from the top. Are you with me? Zena? Okay. Here's your ruler. Excellent. Stay with me. So what the examiner did was he put the mass. Let's fill this up. Let's fill this up with, I don't know, black with a red outline. No, blue outline. Okay. He got his mass, his disk, and he put it on top of the ruler. Can you see the numbers now? No. That is the problem. No matter where you put it on your ruler, you can't see the numbers. So that's a cause of error because you won't be able to measure the values correctly. So that's one problem. That's just a problem. No. Okay, excellent. I think if I do this, it'll be better. Yes, there we go. Okay, excellent. How to avoid this, we'll discuss it later. Mashi? Because I want to go through the rest of the exam first. Okay, question 2. Glad you see it, alhamdulillah. A student is heating water in a beaker using an electric heater. He measures the potential difference V and the current I. So he gave you a bunch of readings here. Write down the readings shown. Now, obviously with their units, but if you haven't noticed the units on this instrument. Yes. Why 3 marks? 1 marks, exactly 3 marks. 1 marks for this reading, 1 marks for this reading, 1 marks for the units. So let's take a look at the readings. This is 8.2. And the other is 0.45, because if this is 0.4 and this is 0.5, this is in the middle. This is 0.45. And this is 8.2 because it's 5 squares, not 10. So 8.2. And then the third mark is for these little things called units. Three marks, easy. Next, because again, he always wants the units. In paper 6, he always wants the units. With measurements like these, he always wants the units. Lays at 0.2 because, hey, count it with me. If this is 8 and this is 9, if this was 8.1, let's count. 8.1, 8.2, 8.3, 8.4, it doesn't work. Because it's 1 divided by 5 divisions, not 1 divided by 10 divisions. So 1 over 5 is 0.2. So this is 8.2, 8.4, 8.6, 8.8, 9. 9. I was like, sorry, bad. That's so bad. That's so bad. Anyway, 9. Okay. What's 0.5? There's no 0.5. No. It's not correct. No. There's no range here. There's no range. This is literally 0.5. See, this is 0. This is 0.2. So this is 0.1, which means this is 0.3, this is 0.4, 5, 0.7, and so on. So if you're halfway between 0.4 and 0.5, you're 0.45. Next. Write down the temperature reading here. Okay, I'll zoom in. And this is 19. So obviously, you have to write it down with the unit. So 19 degrees Celsius, which is already written here, by the way. So paper 6 is very kind. What sign? Which sign? This is degrees Celsius. Oh, this sign. This is a symbol that we call theta. It's a Greek letter. We usually use it when we deal with either angles, because it's measured in degrees, or temperature, because it's also measured in degrees. But yeah. Anyway, next. On figure 2.3, draw a line and an eye to show clearly the line of sight required to read the volume of water in the measuring cylinder. What do I do again? How will I look? I think, the meniscus error and the parallax error. So he just wants you to draw a line to see how will you look at this reading. So just draw a perpendicular line here. Art students be so what do they should. They should. Art teachers too. Draw a line that's perpendicular, draw an eye. That's how you draw an eye, by the way. I know I'm experienced in drawing eyes. I don't know why I am, but I am. And it has to be perpendicular and at the bottom of the meniscus. Okay, I thought of a really stupid pun. Yes, pencil. Yes, pencil, please. Draw it with a pencil. You can draw it with a pen, obviously, but I prefer pencil in case you want to erase it. I just thought of a very stupid pun. I swear it's going to hurt. I'm going to see the participants drop. So yeah, it's a pun because I said why am I experienced in drawing eyes? I was about to say because physics is such a painful subject. You all go eye. Anyway, let's move on. Let's move on, Mr. No. Okay, let's keep going. 13 threes and no, don't you dare. You're done. Oh, I wouldn't be surprised if TE data just closed off my connection. It was like, no, we heard that too. Bye. Oh my God. Anyway, it's funny. Saying puns warms me up inside. Literally, by the way. Warms me up inside, physically. A student is investigating the resistance of a lamp filament. The circuit is shown in figure 3.1. Don't you dare use Star Wars puns with me. The student places a sliding contact C on the resistance wire at a distance of 0.2 meters from point A. So he's gotten this circuit. Okay, sorry, Lion. I know bullets can warm me up, but I don't want that. So you've got a power supply, you've got a switch, you've got a lamp, you've got a long resistor wire, you've got a voltmeter and a meter. So basically what he's doing is he's changing the resistance, and obviously the brightness of the lamp changes, and he wants to measure the voltage and current. We'll see that as we read through the description, but I think you can come up with that just by going through this. So the student places a sliding contact C on the resistance wire at a distance of 0.2 meters from point A. He measures the current I in the circuit and the PdV voltage across the lamp. You'll notice he does this a lot, by the way, when it comes to paper 6. What does he do? He mentions the value and he gives it a label. He mentions the value and he gives it a label. This will happen with every new quantity, even if you understand what it is. Because if he wants to use these symbols later on, like he will do in the next sentence, he needs to define them first. So he then repeats the procedure using values for D, which is the distance shown here, of 0.4, 0.6, 0.8, and so on. Calculate the resistance R of the lamp filament for each set of readings. Use the equation R equals V over I. So pull out my calculator, and for each one of these, calculate V over I. So 1.6 divided by 1, that's 1.6. I don't think I need to Work that out. كده 1.3 divided by 0.86, which is 1.5. Then 1 divided by 0.74. So 1.35. I did something on purpose. I'll wait until you guys figure it out. 0.8 divided by 0.66. It's 1.21. Yes, 3 sig fig. Thank you. Thank you. If he's using 2 or 3 significant figures, I need to exactly. I need to use 3 significant figures. Yes, you are. Now, the first one is just 1.6, so I have to say 1.60. Well, okay, the 1.3 divided by 0.86. So that's 1.51 on my calculator, and so on. Wait, how do you get R again? Well, R is V divided by I. So V divided by I gives you R. This is an equation that we know, but he gave me. Dynamic 1.6 divided by 1. 1.3 divided by 0.8. 1 divided by 0.74. 0.8 divided by 0.66 for each row. For each row, you calculate R. You guys understand now? I mean that's the problem in general, I swear. Again, I know. That's the problem with paper 6. Unfortunately, a lot of you don't see. And not because you're physically blind, la samah Allah, لا خالص. It's because a lot of you lack the focus you need to read the questions. حلو جدا. So this is what I'm warning you about. I'm not reprimanding you. I'm actually warning you. Read carefully. A lot of the times the answers are in the question, especially in paper 6, like specifically paper 6. So please be careful with that. Next one. Complete the column headings. Now we already agreed what a column heading is. This is it. So we have a quantity and a unit. The units are not there. So what's the value of unit for D? Guys, I think you can figure it out from paragraph up there. Meters. Yes. M. What's V? Well, I don't know what voltage is measured in or what current is measured in. Well, I don't know that he probably gave me a question before this question with the units already on their instruments, but I don't know. So V is in A. V is in V and I is in A. And for the first time in forever, he gave me a unit that's not on the actual paper. So I unfortunately have to use my own brain to write ohm. You can either use the symbol or you can use the word ohm. That's absolutely fine. Both are okay. Sherlock Ohms. I know, right? Okay. So here's another table. 3 marks this time around. 3 marks for the entire thing, with less busy work than the previous one. Still. Next. Yeah. This is the part where you have to use your brains, because so far we didn't really use our brains much. Now we have to. The student notices that the lamp does not glow when he takes the final set of readings. He thinks the filament is broken. Like, this is what he thinks. He thinks the filament is broken. State whether the student is correct and give a reason. So what do you think? Is the filament broken? Is the filament broken? No, probably not. But here's the thing. How do we know? Well, we have to go back to the readings. When he said it does not glow, that's what made him think it's broken. But if you take a look here, it's not just that there's resistance. There's something more important. There's what? There's what? A current. Because if the filament was broken, if you broke that filament, there would be no current flowing through the circuit. So you would get no reading on the ammeter, and that didn't happen. That did not happen. So the reason the student is clearly wrong is because, hey, even when it wasn't glowing, there was still a current flowing through. There was still a reading on the ammeter. So that's our answer. What's our statement? He thinks the student is, state whether the student is correct or not. The student is an idiot. And I wouldn't do this. It's not correct. People are going to be up in arms because I said that. Anyway, Student is not correct. Why بقى? Because there is still a current through the lamp. Or you could say there's still a current through the ammeter or a reading on the ammeter. Next. A student suggests that the resistance R should be constant. That's his suggestion. Okay. Suggest referring to observations, to the observation. So we have to go back to the observations. What observation, Minister? Before I read the rest of the sentence. Well, his observation was the appearance of the lamp, the brightness. Oh, well, wait, was the resistance constant? No, it wasn't. It increased. As the brightness increased, it increased. Or you could say the reverse. It decreased as the brightness decreased. But why though? Why though? Because here's the thing. When a light bulb gets brighter, it gets hotter. And the hotter any piece of metal gets, the higher its resistance. That's because the atoms inside start to vibrate more, making it harder for the charges to go through. So the hotter it is, the higher its resistance. You don't understand what it means by constant. It means the value is not the same. So he thought it should be the same, yani 1.6, 1.6, 1.6, 1.6. It wasn't constant. It wasn't a constant 1.6. Okay? So it's clearly decreasing, 1.6, 1.5, 1.4, 1.2. Okay, go ahead, yeah, Abdurrahman. So how do we answer this? Let's read. So suggest a reason why R may not be constant. Well, we first have to refer to the observation, which is A. As the brightness increased, the resistance increased. That's the observation. That's 1 mark. Why though? Because the temperature of the lamp increased. That's the one part that's not in the question. This is something you have to think about. Him changing the distance only changed the current. Him changing the distance of the wire changed the current. Because when he changes the current, if you increase the current, the light bulb will be brighter. If you decrease the current, the light bulb will be dimmer, which changes the brightness, which changes how hot it is. فهنقول as the brightness of the lamp increases, the resistance or its resistance increases because it gets hotter. Good question. Does this apply to all other components? Yes, except the thermistor. If you remember the thermistor, دي كانت السيمبل بتاعتها. This changes the temperature, but this was inversely proportional. If the temperature rises, the resistance decreases and vice versa. Okay? So the only thing that's inverse with temperature in circuits is the thermistor. Everything else is directly proportional to temperature. The resistance is directly proportional to temperature. Again, سؤال ده رخم شوية. So, do you understand this question? So this is the first question you've seen so far that requires you to know some physics. This is some common sense, Malik. Meaning, when a light bulb is bright, it gets hot. That's why you know it gets hot, because it's brighter. And when the light bulb is dim, it's not glowing. It's cold, it's cool. Oh, look, you see the problem with this question, as far as I'm concerned, is your own personal life experience. Most of you have currently grown up with LED bulbs. The problem with LED light bulbs is that they don't get hot. They get slightly warm, but they don't get hot. Older filament lamps, and I'm sure you've seen this in YouTube videos or anything else, maybe some of you have it in your house, if it's an older light bulb. The light bulb was made of a very thin coiled wire, which we call a filament. The way this filament light bulb worked was when you pass the current through it, the filament would get hot. And the hotter it became, the brighter it would glow. This is why if you open up an electric oven, لو فتحت فرن كهرباء, and you turn it on, you will see that filament, that rod inside, getting brighter and brighter and brighter and red and orange and yellow. Why? Because it's getting hotter. The hotter a piece of metal becomes, the more it glows. Okay, obviously this means they easily get damaged because obviously over time the heat ruins the filament, or it ruins the spacer between the filaments because you have to have a piece of metal in there that stops them from touching each other so they don't overheat part or like short circuit. Yes, that's why they explode very often. Okay. Next. Name an electric component that could be used instead of the resistance wire AB in sliding contact. What was the name of the component that has a slider and a wire and that slides back and forth and you can change its resistance? It's a variable resistor. Some people are like in all caps, but I like this excitement. Variable resistor. Part 3. Draw a diagram of the circuit including this component instead of the resistance wire and the sliding contact. So he wants you to redraw this circuit, so supply, lamp, voltmeter, but replace this part with the symbol for the variable resistor. If you don't remember what the symbol was, I'll just draw it aside here. It was this. So here's how I would draw this. Supply, here's the light bulb, here's the voltmeter parallel to it, and here's the resistor with an arrow through it, exactly. And then he drew the ammeter, and he closed. Was there a switch? I just want to be sure. Yeah, there was a switch, so let me erase this. Switch, and there we go. Just redraw the entire circuit. The only thing that's new is this. The only thing that's new is this. No, you don't have to draw the circuit with a ruler, no. Yes, you get 2 marks for us. There's 1 mark for the symbol and 1 mark for the correct diagram. Does it matter where you place it? Yes, it does. You need to place it exactly where the old sliding wire and sliding contact and resistance wire were. Just draw the exact same. And it's as if I did this. As if I just erased this. I took this diagram, erased this entire thing. And then I just put this in place. Okay? Because he drew a power supply. So I draw a power supply. He said, draw the diagram of the circuit, including this component. So I'm just copying the same diagram. No need for safety precautions. Okay? Okay. Do any of you have any questions here? No? Okay, no. Do not try to. That's a good safety precaution. Do not eat the circuits. Okay, hi, Lan. Ziad says C. I did. Now, I'll get back to you later, Lan. Now, Ziad, Tani, a student suggested the resistance should be constant. So he will do this a lot, Ziad. He will always have 1 question in the entire exam, at least, where he gives you an idea and he asks you why this idea may not be right or wrong. So his idea is R should be constant. So if you go back to the table, is the value of R constant when he was changing the distance? Because that's what he suggested. He was suggesting that R should be the same. Was R the same? No, it wasn't. حلو. So you're on the first right step. Okay. Then the next step. Why is it not constant? Well, based on what we see, the brightness of the light bulb is changing, which makes sense because, you know, we're increasing or decreasing the current here. So the more current is flowing through the lamp, the brighter it'll be. But the brighter the lamp is, and this is about where you have to put in your own experience / common sense / stuff I've told you about. The brighter a lamp is, the hotter it is. So why is that related to temperature? Because the higher the temperature of a lamp, the higher its a resistance. Because when the temperature of any metal increases, its resistance increases. So when he asked you about suggest a reason why the resistance may not be constant, well, that's because the light bulb is getting hotter. Did you notice what I did, Yazed? I skipped this part. So let's add it back. Refer to the observation. What observation? And it was getting brighter. The resistance increased because it was getting brighter, or when it was getting brighter. So what's my answer? The resistance increased when it got hotter, which was clear because it was getting a brighter. Because the brighter a lamp is, the hotter it becomes. يعني كل ما البرايتنس تزيد بتسخن. هي actually العكس، هي بتسخن فالبرايتنس بتزيد. Get the idea? حلو. Nice. Moving on بقى. Oh yes. Yes, this is the question we're waiting for. This is the question we're waiting for. Oh no. Oh no. Oh no. What am I going to do here? The menacing one. You know the meme that SpongeBob was like standing there menacingly. Here's the question in the paper, sitting there menacingly. Anyway, this menacing looking question is simple. That's going overboard, Selma. Mercury tempting to drink? It's not. Now, a student is investigating the effect of insulation on the rate of cooling of hot water in a 250 centimeter cube container. The student can choose from the following apparatus. He just gave you a big list. And then plan an experiment to investigate the effectiveness of the 3 insulating materials, and you should do the following. Before I start though, this is what we call the planning or investigation question, the planning question. In order to plan an experiment, there are a few steps that you need to take. Step number 1, what's the experiment going to be about? بالظبط اللي هنعمله. At least at our level, the function of all experiments is to investigate the relationship between 2 things, nothing more. You're going to be changing one thing and seeing how the other is affected, which you used to call the independent and the dependent variables. I'll mention that now. But when you plan any experiment, there are always 2 quantities. One of them you physically change, and it doesn't have to be measurable. Maybe you're just changing the material. And the other is a quantity that you measure. So if we just read the first sentence before we go on to the rest, a student is investigating the effect of insulation on the rate of cooling of hot water. So what's he going to change? What do you think he's changing? The insulation. And what's he going to measure? The rate of cooling, how fast it's cooling, the time that it takes to cool. This is what we call the independent and the dependent variable. The word independent means it's not affected by other things, whereas dependent means it is affected by the other thing. إن لو فكرت فيها, what do you think affects the other? إن أنا أغطي, like if I have a beaker, if I have my cold cup of tea now, unfortunately it's cold, and I wanted to see how covering this with an insulator affects the rate of cooling. Is the cooling affected by the insulator, like if I cover it with rubber or wool or paper? Or does the paper depend on the cooling? Or like, does the cover depend on the cooling? It's the cooling that depends on the cover. So the independent اللي هو ملوش دعوة بالتاني is what you change. The dependent اللي بيعتمد على الأولاني, like that depends on الأولاني, that's what changes. So before I even go on, let's discuss this freely. Independent and dependent. Independent and dependent. What do we do? Well, logically, هجيب أكيد container, like he said, a 250 centimeter cubed container. So here is a 250 centimeter cubed container. And then what do? Actually, it's a 600 centimeter cubed container, but still, never mind. So if this is a 250 centimeter cubed container, what do? Well, I need some hot water. I put some hot water inside. And I need to measure how it cools. So I need two things. I need a thermometer and I need the stopwatch. Plop. I'm not going to put this in the water. It's going to ruin my pen. Plop the thermometer into the water and start the stopwatch. And you see how the temperature cools, how much time it takes to cool. Because rate of cooling, like we previously agreed, احنا قلنا rate of أي حمادة is what? Over time. So cooling over time. So we're going to measure how much time it takes to cool. And then what do you change بقى? Then I get, I don't know, a crumpled sheet of paper and I cover the beaker with it and repeat the experiment. Exactly, get different insulators. Okay, I tried it with paper. Let's try it with some cloth. Let's do this again. Let's try it with some rubber. Let's try it with some cotton. Let's try it. So you're just changing the insulating material and you're measuring the rate of cooling. You're not actually going to do it. We're just thinking what we're going to do. You're going to go tell him to, just like how in paper 6, in the previous questions, he tells you what the student has done. You go tell the student, روح انت اعمل experiment. You go do the experiment. I'm not doing it, you do it. But you have to tell him how. So we're just going to mention it step by step. Okay, we told the student to go do the experiment, then what? Well, at least he has to put it in a table, maybe draw a graph, maybe mention a precaution, maybe keep other things constant. Mister, how do I keep all of that in mind? The only thing that I need you to keep in mind is the very first thing we said. When you are planning an experiment, you need to know what the experiment's about. What's the independent and what's the dependent. That's all you need to remember for now. Because everything else will be asked of you. هيفكرك بيها. You will be prompted. فبص بقى. The student can choose from the following apparatus. He gave me a list. So you remind me there's a thermometer, we have a glass beaker, a plastic beaker, a copper can. You don't have to use everything. Sometimes he puts extra apparatus in there to confuse you. So glass beaker, plastic beaker, copper can, measuring cylinder. 3 insulating materials. Oh yeah, we need this. And we definitely need the thermometer. And the clamp, boss, and stand. If you don't know what a clamp and stand is, it's basically this. If I have the beaker, and we're going to have water inside, and we're going to put the thermometer, I'm not going to hold the thermometer with my hand because I'm also busy using the stopwatch, and I'm also busy writing the values down. So I need something to help me hold the thermometer. That's what a clamp and stand are. So this is your stand, and this is your clamp. It holds onto the thermometer or the test tube or something. The boss is me. Obviously not. No. The boss is this. It's just a piece of metal that holds the clamp and stand together. So that's why they call it the boss, because it holds everything together. And a stopwatch, obviously. So he gave me all the apparatus I need. Okay. Plan an experiment. Exactly. Plan an experiment to investigate the effectiveness of the 3 insulating materials. So he just wants you to plan things. Now remember, I told you he'll prompt you. So first, explain briefly how you would carry out the investigation. And he wants the steps. State the key variables you would control. The word control means what will you keep constant. Draw a table with column headings to show how you would display your readings. You are not required to enter any readings. So just the heading. Temperature, material, time, whatever it is that we're doing. explain how you would use your readings to reach a conclusion. This has one of two things. You either tell him what the conclusion is, or you just go tell him, hey, draw a graph. Just like how he tells us to draw a graph using the previous values. We go tell him, hey, draw a graph. But we have to tell him what's on the x and what's on the y-axis. We'll see that in a bit. Okay? A diagram is not required, but you may draw a diagram if it helps your explanation. I always suggest to draw. Why? Because part of the steps that you have to mention in part A, remember this is part A and B and C and D, part of the steps in part A includes describing the apparatus. But instead of describing how to assemble the apparatus, I prefer that you just sketch it. عشان توفر على نفس الكلام, so you just don't have to write too much. فمثلا, in this case, instead of, I don't know, explaining us, hey, get the beaker, I'm going to choose the glass beaker, for example. So I'm telling him, hey, go get the glass beaker and fill it with hot water and put a thermometer in it and hold the thermometer with a clamp and stand, and then you can start the measurements. I can just skip most of it and say, pour the hot water into the beaker as shown and and just jump into the measurements. Because I've already shown him how I'm using the thermometer, how I'm using the stand, how I'm using the beaker. Okay? Now, if you understand what I'm saying, let me just show you the diagram first. Here's how I would draw the diagram. It's just like the one I've sketched up there, but I want it down here. I would draw a beaker. And I would label things. I would say hot water, glass beaker. I'll draw thermometer, and stand and clamp. وممكن نرسم something like fluffy here, the sides, and I'll call that insulation or insulator. So there's something that you need to understand in physics, because you just mentioned a very important statement that is good. It's a good precaution, but it pointed something out. In biology, I think, and I don't like, again, don't quote me on this, I think they tell you to do the experiments in the same time, like at the same time for fair comparison. We don't do that here. We do each experiment separately. We keep the variables between them constant. Like we keep certain things constant when we repeat the experiment. But you are a human being. You have, alhamdulillah, 2 hands, plus a pair of eyes, and 1 brain. Hopefully it's working. I can't do 4 of these or 3 experiments at the same time. I don't have enough hands. So it will be very unfair if I pour the hot water here, pour the hot water here, pour the hot water here, start the stopwatch here, start the stopwatch here, start the stopwatch here, keep writing down the readings here, writing down the readings here, writing down the readings here. I do the experiment once, and then I tell him I repeat it for the other insulating materials. Okay? I'll show you where to draw it, Iljan. Okay, so what's my answer going to be? I'm going to scroll down. But remember, step by step, explain briefly how to carry out the investigation. Here's how you start. I'm just going to type it all here. So how do I start? I would say, pour the hot water into the beaker. Because that's an action that you have to do. Sure, I've already assembled the apparatus, but that's an action. Now, here's the thing. How do I measure rate of cooling? How do I measure rate of cooling? The easiest thing to do is to measure the time taken for it to cool. خلاص? Time taken for it to cool for a fixed change in temperature. So you measure the initial temperature, you measure the starting temperature. Restart your Zoom, yeah, everybody else can see it. Can you all see the screen, by the way? Is anybody else not seeing the screen? Yeah, can see. Okay, good. Everybody can see. Just restart. Exactly. So you want a fixed temperature difference and you just measure the time. There is another way. You can measure the temperature difference in a fixed amount of time. يعني هقول starting temperature بكام? Wait 30 seconds. What's the final temperature? So you've now gotten the rate of cooling, how much it's cooled by. So you can do them in different A orders. They're both okay. So I'm going to do the first one. So measure the initial temperature. Start the stopwatch. Measure the time. Let me just separate these. Measure the time for the temperature to decrease مثلا by 50 degrees or to room temperature. Okay, then repeat the experiment. Repeat the experiment for all the insulating materials, the three he used. So if you noticed, what did I do? I started the measurement, told him exactly how to use the stopwatch. Treat him like a child. Treat him like a child. The question is not over. That's just part A. I just left a lot of spaces so you can see what I'm doing. Treat him like a child. Start the stopwatch, what to measure the time, when to stop the stopwatch, stuff like that. So, are we done? Well, we're done with the measurements. Like we're done with the measurements part. How to make? Why is it taking this much space? Oh, okay. I think I know what's going on. Or not. Okay. That's the first part. What are the key variables that I would control? Like, what would I keep constant? Well, if I'm going to be repeating the experiment 3 times for the other insulators, I need to use the same amount of water. Now, that's only fair. That's for fair comparison. The same temperature of the water, thank you, Malik. That's only fair. Use the same beaker. This is the trick he had here. This is the trick he had here. This is the trick he had here. Which is hey, I gave you different beakers. I don't need them. I just need one beaker. I'm changing the insulation, not the beaker. So basically, what are the things that you will use that are the same? So here's what we do. Use the same. نكتبهم بقى كلهم. Volume of water, initial temperature, initial يعني starting, of water, and same glass beaker. I don't care about the thickness of insulation because I'm changing the insulation. So for now, that's what we change. That's what we keep constant. Draw a table or tables with column headings. Show you display readings. Now, if you remember, your table must have at least 2 things: the independent and the dependent. So the independent was what? The independent was what? The material. I changed the material. The dependent was what? The time. I measure the time. So at least I have 2 columns. I should at least have 2 columns. That's why I only use the simpler version today. So you can either draw the table here, like if you've left enough space for yourself, you can either draw the table here. So it would look something like this: material and time in seconds, cooling time مثلا. And then you would close this off so it looks like a table. But mister, what if I don't have enough space? You're not going to fill this up with anything, no values inside. Well, just type it here. Just do it here. You would go like this. Material, cooling time / second, and thank you. And then you'll draw a table around it. I'll draw the table in the end because it's clearly like being annoying. with the spaces. So I'll just draw the lines around it. In the lines, that's fine. That's why he's giving you so much space. Finally, بقى, we've already finished A, B, and C, and D. How would you use the readings to reach a conclusion? Well, since I chose to use easier numbers, like which one is the best insulator? We would say the best insulator would have the longest cooling time. So I'll just tell him, compare the cooling times. The one with the longest cooling time is the best insulator. I don't know what he used, but I'm just giving him a general conclusion based on the values that he should have measured. So I would say something along the lines of, compare the cooling times of the different insulators. The one with the longest time is the best insulator. And you have your answer. Let me draw a table around this so it looks nice and snazzy. Bam. Here's your answer. Now let me zoom out for effect. Notice I'm leaving a lot of empty space. How much did we actually write? How much did we actually write? Not a lot. If you think, Iowa, they just want to scare you. If you think about it, what are the 7 marks for? Well, if you think about it, maybe this is 3 marks because you're mentioning a lot of steps. Maybe this is 2 marks, and maybe this is about 1 mark, and this is 1 mark. So he splits them up. Sometimes it's 2 marks and 2 marks, and then he'll have another step that you add. It's just split up. It looks scary, but you just split it up. الإكزامينر مش سالك. من إمتى وهو سالك؟ He's never سالك. He's never okay. He's never easy going. عمره ما يبقى سالك. So you see this? Now I will send you the document, the solved version, because I want to finish up the next question. We're never mentally stable. Physics teachers are never mentally stable. At least I think we're not. And examiners are even worse than us. So now, it's a badge of pride. Moving on. No, it's not. Don't quote me on that. So next. A student determines the last question in this exam. A student determines the focal length of a lens. The apparatus is shown in figure 5.1. The student places the lens at a distance u from the illuminated object. He moves the screen until a sharply focused image of the object is seen on the screen. Measure the distance u. Unfortunately, I'm gonna have to do something here. I have to put a sheet of paper on top of my screen to make sure I've zoomed out the correct scale, because this is literally a measurement question. Yeah, this is exactly what an A4 sheet of paper is scaled like. So what do? Get your ruler and measure the distance u on your paper. So this is going to be 5 centimeters. And since I know he's going to ask me to measure V, it's going to be about 2 centimeters. So this is 5 centimeters and this is 2 centimeters. But just like Zaina pointed out, Mister, it's not in centimeters. He wrote the unit this time. It's millimeters. So I would say 50 and 20. Be careful with the units. Thank you. Exactly. Because I was just using my ruler to measure. So yeah, literally measure the distance on the paper. Now, lens questions will always do this. They'll ask you to measure something, and then the scale, the figure is drawn to scale. It's 1/10 of the actual scale. Yes, it does have a range. A very small range, like a millimeter range. But honestly, in the final exam, this won't have much of a range. By the way, let's talk about this seriously. In the final exam, this won't have a range. With you guys, there is a range. Why? Right now, because when past papers are photocopied or printed or anything, when exams are photocopied or printed or anything, your printer changes the scale of the print. Sometimes it's like 97% scaled, 94% scaled, 98% scaled, 100% scaled. So it'll change from one person to another. But 4 centimeters, that's a bit too much. Is it 4? No, it's 5. So if it's 4.8 or something, 4.5, yeah, that makes sense. Like a full centimeter difference is a lot. Make sure you place your ruler like this, and you're measuring the distance from this point to this point, and then from this point to this. 4 centimeters is actually really small, even if the printer shrinks the page a bit. So the actual size of U, well, since he said it's 1/10, exactly like you guys said, 4.6 is fine, 4.5 is fine, 4.8 is fine, stuff like that's okay. But an actual just pure 4 is no. 4.0 is actually like a bit too small. Calculate the actual distance U. Well, if this is 10 times smaller, then the actual distance is 10 times bigger. So 500 and 200. So it's basically 50 times 10 and 20 times 10. Okay. What else? Calculate a value f1 for the focal length of the lens using f1 equals uv over u plus v. Mr. Amarshi, I don't know what this equation is. I've never seen it before. And wait, he gave me the equation. And U capital, V capital, I already have. So I can calculate this, right? So F equals U, which is 500, times 200 over 500 plus 200. Now, I'm going to get a question now, which is, I'm pretty sure, why did you use the 500 and 200 and not the 50 and 20? Because in his equation, he used the capital U and V, not the small U and V. The examiner is very particular about the symbols he uses, or they use. Right. 500 times 200 divided by 700. This gives me 142.9, or I could just write it as 143 because we prefer 3 significant figures. But that's fine. 142.9 is fine. Why is times 10 and not times 1 over 10? Because, read carefully, the figure is drawn 1/10 of the actual size. The figure is smaller than the actual size 10 times. أصغر من الحقيقي by 10. يبقى الحقيقي إيه? The real size of the diagram is 10 times bigger. Okay, so moving on بقى. Easy numbers. A second student repeats the experiment 3 times using a different lens. His values for the focal length are shown. Calculate the average. Well, how do I calculate the average of 3 numbers? This is math بقى. 132 plus 141 exactly plus 135 divided by 3 because there are 3 numbers. So 132 plus 141 plus 135 divided by 3. This gives me 136. That's it. That's it, literally. A third student, my God, these students, is using the same method, finds that the focal length of her lens is 200 millimeters. Okay, that's the F. She reads in a book that when U equals to F, U and V, as shown in 5.1, are equal. What does he mean? He says that when U and V in 5.1, what's 5.1? Mister, go up, 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 up. Oh, that's U and V. So these two are supposed to be equal. According to her, these two are supposed to be equal when the U is to F. What is to F? This is very hard. This is very, very hard. 400. Why? Because it's 200. Mister, why didn't you use the previous F? Because this is called F, not F2. Why didn't you use the first F? Because this is called F1, not F. Besides, it's a completely different student. He is very particular about the symbols he uses. So if he says, what's 2F? He was 400. Okay? So she reads in a book, when U equals to F, U and V should be equal. All she's trying to say is, he used A, these two should be equal. And I don't care if he used the small u or big U. All I care about is, he said that, he asked me to calculate 2F. He asked me to calculate 2F. And what's 2F? Here's F. F is 200. 2F يعني 2 times F. That's it. So 2 times 200. Next. The student sets up the apparatus shown and she adjusts both X and Y to be 400. So she did the experiment. I'm not going to have to do anything about it. She adjusted this to be 400 and 400. However, this was not 400 and this was not 400. This was 400 millimeters. And then the student slowly increases distance Y and she obtains a sharply focused image when Y is 406. Oops, it's not 400, it's 406. Discuss whether the student's results confirm the statement. Are these equal? What would you say? Yes or no? Would you say that 400 is equal to 406? I would say yes. I would say, I told you, math teachers hate me. You know those ads? Math teachers hate. I was like, math teachers hate me. Why? Because I'm trying to say that these two numbers are equal. Why? Because 6 is such a small difference. Because it's very small and within limits of accuracy, just like we used in the very first question. But I would say yes, because the difference between 400 and 406 is very small and within limits of accuracy. Okay. I mean, 6 compare. Oh, sorry. Stop. 6. What? Okay, sorry. It's bugging out. Just give me a second to refresh that. Okay. The number 6 compared to 400 is small. It's not that the number 6 is small. The number 6 compared to 400 is small. And again, but how do you get that range? Like, how do you get that value? How do you know if it's small or not? I told you, our limit of accuracy, now I can say it clearly, is 10% of your value. What do I mean? Do you see this 400 that we're talking about, or 406? What's 10% of it? If you multiply 400 times 10% on your calculator, which is just like dividing by 10, by the way, it'll give you 40. So your limit is 40. That's a difference that's large. Okay. Relative to our numbers, بالنسبة لل 400, 40 is a big number. 6 is not a big number because it's less than that. Okay? And Cambridge would not have cared, Jane, unfortunately. So, no. Okay. Next thought. So I would say yes. Finally, suggest 2 precautions. Is it? Yes, exactly. It's always 10%. Suggest 2 precautions that you would take in this investigation in order to obtain reliable results. Now, every experiment has its own precautions. Repeating and averaging is not a precaution that we like to use. For now, use that if you ever forget any of your precautions. But here's what I would suggest. That every experiment has its own precautions. Memorize 2 of them for each experiment. Right now, this is a lens experiment. With lens experiments, the first precaution is that you have to do this experiment in a dark room. Why? So that you can see the screen. Just like when we use a projector in class. If we turn the projector on and the room is bright, the screen is not very clear. It's not very sharp. But if you switch off the lights, you can clearly see the projector screen and you can adjust the focus. You can adjust how sharp it is because the room is dark. Second precaution. Do you see this lens and this opening? The opening and the lens have to be at the same level. Because sometimes you can change how high this lens can be. And so these have to be at the same level. Because if your block that's supporting the lens is too high and the lens is too high, the light doesn't even get to the lens or it gives you a bad image. Another thing you have to do is if you're moving the screen or if you're moving the lens to get the image, move it very slowly, which is why she used the word slowly. Because if you move it too fast, you won't get to see the proper focus. So what would I say? I'm going to choose the two very common answers I prefer to say, which were do the experiment in a dark room and lens or the lens and object need to be at the same height or level. You could also mention the one we previously mentioned, move the screen or lens, see what he moved in the experiment, okay? Very slowly to find the image. Then the first point is very simple, which is what? If you do the experiment in a dark room, you can see the screen clearly. If it's bright, the outline of the screen, the outline of the image will be hazy because it's very bright, so you don't see the image. Yes. So that's why we do it in the dark room, so you can clearly see the difference. Okay. To the person who wanted C, the answer is 136. C is 136. Wow, that took a while. But the reason it took a while is because we're explaining every single little detail. If you haven't noticed, paper 6 is very simple. The only question that needed me to think a lot, or just a bit, was what? Was that electricity question, which asked me to, hey, can you give a reason why the resistance is not constant? So we had to think about that. Even the planning question, question 4, was just me following steps that were given to me. Now, you will get better at it with experience. Lots of problem solving, lots of practice will eventually make you a lot better because you end up seeing all the possible experiments that the examiner could get in paper 6. Because unfortunately, the questions are repetitive. There's only a limited number of experiments that you can experience, at least at your level. Okay, I think we'll stop the session here. We'll end the session here. خلاص, it's 11:15 or so. That's more than enough time. And let me stop the recording here so it doesn't get too long. Bye, guys who are just watching the recording. Have a nice day. Bye-bye.